Hello class and welcome to chapter 10. We're looking at section 10.1, which is to solve quadratic equations using the square root property. Okay. So a quadratic equation, we're entering into a new world of equations. We've seen a lot of linear equations. So quadratic equations, let me write it out here. It's all about the degrees, right? The degree of the equation, the polynomial. So I will say a quadratic equation is a polynomial, meaning it has many terms, of degree 2. Okay, so if you have the variable carrying the power 2, the degree is 2 of that polynomial, then you know we're talking about quadratic equation. If it's a quadratic equation, the shape is a parabola. Okay. Parabola is U-shaped. Either it opens upwards U-shaped or it's an inverted U-shaped graph. So it's not a line, of course. If it's a line, we call it linear. So this is a parabola that you get when you have a quadratic equation. Okay, that's the idea of quadratic equations. But we're going to use square root property to solve quadratic equation. So what does that mean? So they're saying if x squared equals k is an equation, clearly you look at this equation, what is the degree of this equation? The degree is 2, right? Highest power. So the degree is 2, meaning this is a quadratic equation. And they're saying, well, k must be positive, this is 0 or more, right? If that's how it is set up, then it implies x is either square root of k or x is negative square root of a. I would like to combine these two into a single expression with a plus or minus. Okay, so x is plus or minus square root of k. So let's look at this with a quick example. Okay. So let's say, in fact, we saw this in chapter 9 when we were talking about, let's say, square root of 9, right? So you're asking yourself, what squared is 9, right? That was our question, to find the square root. Well, we could use the calculator, but if you were reasoning it out, you're asking yourselves, what squared is 9? And the first thing that comes to our mind is 3, right? Because we say, oh yes, 3 squared is 9. But if you scan it closely, you will also find that negative 3 will work, because negative 3 when squared also gives you a 9. I discussed this briefly in chapter 9. That's the whole idea here. Well, in chapter 9, the definition there, then, we were not using the property, we're just using the definition of square root. And so when we did the definition, it wanted us to only consider the positive number. And so we chose only the positive 3 as the answer. But here, when we're talking about solving equations, there it was not an equation, it was just finding the square roots. But here, when we're solving equations, we need to consider both possibilities of plus and the minus. Okay. So you see the plus and the minus, there are two answers, but they're combined in one in this notation. Two answers. Okay. One is positive, another one is negative. All right, so let's also look at these steps when we consider solving using square root property. You want to isolate the quadratic term and make its coefficient 1, okay? So we really want to get the square term, okay? Let me write it out here. Get the term with square isolated on one side. Okay. Only when you do that can you apply the property. Only then can we apply the property. And after that, you will simplify and then check the solutions. Okay, so just remember this. Get the square term isolated on one side. Okay, let's look at the first problem. We have x squared equals 169. So that's your step 1. Is your square term isolated on one side? Is it separated on one side? Yes, step 1 is already done for us. Are we ready to use the square root property? Yes, we can. You go to step 2. Step 2 says, well, square root a property allows us to simply write this as plus or minus square root of 169. So the x squared now becomes an x because you're trying to solve for x. So the x squared goes away and it becomes an x. And the square on the other side becomes a square root, right? So it's plus or minus square root of 169. That's step 2. Now it's time for us to simplify this. Square root 169, the radicand is 169. Therefore, what squared will give you 169? It's 13 squared, so it's 13. So x is plus or minus 13. Okay? There are two answers. This means x equals 13 or negative 13. There are two possibilities there, right? So when we check the answer, we want to check for both of them. Okay? I'll do the check for this problem. For all other problems, you will perform the check yourself. So 13 squared, is that equal to 169? That's one solution. And negative 13 squared, is that equal to 169? Because we got 13 and negative 13. So yes, we get 169 equals 169. And this is negative times negative, which is positive, and 13 times 13 is 169. And that's also good. We come back and box the answer. Again, if your software allows you to enter with this symbol, that's fine. If not, you will enter them separately with a comma in between them. Okay, let's go to the next problem. 5m squared equals 80. So go to step 1. Okay, step 1 is to isolate the square term. To get the square term by itself, we have one more step to do, which is to divide both sides by 5 so that we get the m squared by itself. You don't want any other number there. So go ahead and divide these two. Now you're still in step 1, right? So you are trying to get m squared by itself, and then we go to step 2, which is to apply square root property. So that will be m equals plus or minus square root of 16. Please remember the rule. The property is that, okay? The m squared becomes an m, so that you're solving for m. And 16 will now be square root of 16 with two options, plus and minus. Okay? M is plus or minus 4. Once again, you can split it up as 14 plus 4 or a minus 4. Please do the check. How about this one? X squared minus 48 equals 0. Okay. As always, step 1. So step 1 is to isolate it. So I need to get rid of the 48. So I add 48 on both sides. Okay. Another thing, if you go back to the property, let me quickly take you back to the property here. The property, right? Remember we said this k must be positive. Okay, it can be 0 or positive. So that's another thing we are tracking. Okay, let's come back here. See here, this was positive. Again, don't look at the 80 yet. Okay, you want to look at this step where it's after isolating. After isolating, this was positive, because if it was not positive, you cannot really use the property, right? Come here. Yes, after isolating, this is positive. And therefore, we are guaranteed step 2, which is x equals plus or minus square root of 48. Now, 48 is not a perfect root, so we have to go back to the old idea of splitting them up, right? 48 and 16 will work. Right? We know this just from our knowledge of numbers. If you don't, you can always, if you didn't identify it, you can always go back and collect your variable, your factors. 16 and 3. Remember, 4 also works. 4 and 12, but 4 is not the highest perfect square you can find. 16 is the perfect highest perfect square root you can find. All right, so that's plus or minus. So plus or minus is happening outside, so keep tagging that along. 16 times 3 plus or minus square root of 16 times square root of 3. Square root of 16 is 4, so 4 root 3. So x is plus or minus 4 root 3. So go ahead and split them up as positive 4 root 3 and negative 4 root 3. Okay. Let's look at this last problem. Q squared plus 24 equals 0. Okay, let's isolate this. Q squared plus 24 equals 0. Minus 24 minus 24. Q squared equals minus 24. Okay, right there, we always keep checking after we've applied step 1 to see if this is positive. This is not positive, so we cannot really be guaranteed an answer in step 2. So let me just illustrate that here. So in step 2, if you use the square root property, it's plus or minus square root of negative 24, right? We know that square root of, okay, of a negative radicand does not produce a real number. Right? Because any number times itself will always be a positive number. Even if you started with a negative number times itself is another negative number, right? The same negative number. So it'll also give you a positive number. So there's no way you're going to find an answer that will give you a negative result here. Okay? So there is no real solution here. And so that's a nice catch in the last problem, where if you do not have a positive number after you have simplified in step 1, you will not be guaranteed a real solution as the answer. So you really have to end up saying Q doesn't have any real solution. I hope that helps. I'll see you in the next video.